There's another aspect of solutions that you should know about that can heavily affect our body and our homeostasis is pH. pH is basically, you may have seen or you may have measured the pH of some solutions like even the pool, a swimming pool. If the pH of a swimming pool is too acidic or too low, then you can get chemical burns. The same thing is true if it's too basic. The basic ones actually tend to cause more skin burns. What pH is it's the amount of hydrogen ions So when we're measuring the pH of something, we're looking for how many hydrogen ions are freely floating in that solution. So acids are proton donors. They have a lot of free-floating hydrogen ions, and they can release hydrogen ions when put in solutions. So an example of that is going to be hydrochloric acid. When you put hydrochloric acid into a solution, it will dissociate into a hydrogen ion and a chlorine ion, or a chloride ion. And so hydrogen increases and the pH will drop. Acidic solutions have a higher concentration of hydrogen ions. That's what these brackets mean, is concentration. Something to be very, very aware of and not get accidentally confused on. If we have a higher level of free-floating hydrogen ions, we have a more acidic solution. And on the pH scale, we have a lower pH. So anything actually below 7 on the pH scale is considered acidic. So this is all acidic. So a decrease in pH is an increase in free-floating hydrogen ions. Make sure you remember that and think about that clearly, because a lot of people make some mistakes just by confusing those two. The pH range of an acidic solution is from 0 to 6.99. So like I said, 7.0 is considered neutral. Anything below 7 is considered acidic. Bases, on the other hand, are going to be opposite. They are going to be willing to accept freely floating hydrogen ions. And so they're going to take up hydrogen ions from solution. Generally, they are hydroxyl groups. So sodium hydroxide is an example of a base. If you put sodium hydroxide into a solution, it will dissociate into sodium ions and hydroxyl groups that will be free to join up and make bonds with hydrogen ions to form water. So they will bond and they will form, water. All right. Bases are also known as alkaline solutions. So alkalinity is more basic usually. The opposite is going to be true with alkaline solutions. They have a decrease in free-floating hydrogen ions because they have hydroxyl groups that are ready to bind hydrogen ions. But on the pH scale, the number will go up. So everything above 7 is considered basic. And that pH range will be from 7.01 to 14. Again, neutral solutions are where the amount of hydrogen ions and the amount of hydroxyl ions are about the same. And that's at a pH of 7. Acid-base balance and having this pretty even number of hydroxyl groups and hydrogen ions is super, super important in our body. Our blood pH range is from 7.35 to 7.4. So we're a little bit more on the basic side, but it's a very important range to maintain. Once you start to get out of that range, the body works very, very hard to try and keep you in that range. In fact, a slight change outside of that range can even lead to death. The pH is regulated by the kidneys, the lungs, and buffers. So we have internal buffers that are kind of like hydroxyl groups that will bind to free-floating hydrogen ions when we get too acidic. You'll learn in AMP2 about how the kidneys and the lungs help regulate pH. The buffers are going to be, like I said, something that's going to keep from the pH from going too low or too high. Most of the time, in our bodies, it's going to be something that keeps it from becoming too acidic. So we have hydroxyl groups that are going to resist the pH change. They act as buffers and bind those free-floating hydrogens and cause the pH to not get too low or too acidic. And then we also have some hydrogen buffers that will help if we become too basic. It will help the blood to come back down into its proper range. Bicarbonate ions are the example of the base that will bind hydrogen ions and help keep our blood from becoming too acidic. Ammonia is an example of an acid that will join hydroxyl groups if we're becoming too basic and help. And ammonia is another example of a base.